So what is the question? We have a block of weight 100 Newton lying on a horizontal surface just begins to move when a horizontal force of 25 Newton acts on it. Determine the coefficient of static friction. See, it is beginning to move. Means what light is there on the traffic signal? Yellow. It is about to move. Okay. So when an object is about to move, it means the force applied is what? Just equal to Fs max. Right? If the force applied is equal to Fs max, it means object will have a tendency to move. But the moment force is greater than Fs max, then it will start moving. And what friction will come into picture? Kinetic. This is the basics of friction. So let's draw the block. So we have a block. Weight is 100 Newton. So you apply a force of 25 Newton. Students, if you read the question here, they are telling that it is about to move or begins to move. It means that the force what you have applied is almost equal to Fs max. Any problem in this? The force is 25 Newton. What is Fs max equal to? Mu s into N. So what will be normal force equal to here? Weight of the object. Normal force and weight will be equal in this case. So normal will be equal to weight in this case because upward force will be equal to downward force. Object is not moving in the vertical direction. Upward force, downward force equal. So what will be mu s equal to, students? 25 by 100?
0.25.
0.25. Simple question. Any problem? You just need to know how to decode the question. Whatever data is given, you need to know how to read it. What is the unit of coefficient of static friction? See the formula. What will be the unit of coefficient of friction? See the formula. Force is equal to mu s into normal force. So what will be the unit of coefficient of static friction? No unit.
No unit because
Dimensionless.
of normal.
Dimensionless. So see here, force. Normal is also what? A force. Force by force. What will be dimension? Nothing. If you divide any quantity with the same quantity, what will be the dimension? Nothing. Dimensionless. So what will be the unit of this? Nothing. It's basically a coefficient. It is just a value. This is dimensionless. And don't try to remember it. The explanation is in front of you. Force by force. This has to be dimensionless. All clear, students? Any doubt? Check. Revise this chapter. This chapter is not difficult. I'm telling you. Because you're reading it for the first time, many new things you're seeing. That's why you may find it difficult. But if you practice, mark my word, if within 1 week you will be master of this chapter. And once you are master of this chapter, next 3-4 chapters you will enjoy. The moment it happens ulta, I don't know what will happen after. Okay, all the next 4-5 chapters are depending because if you don't know how to draw free body diagram, if you don't know how to write force equation, you cannot sustain in the other chapters. Everything depends. This is the ABCD of next 4-5 chapters. That is the reason I'm teaching very slow also. From next chapter, speed will increase. Okay, and there we will not discuss how to draw free body diagram, how to write force equation. I will just write. So please revise regularly. Copy the question. I know the figure is a bit blurry. So basically, what is this? This is the physics book. Are you guys able to identify what is this figure? Physics book or any book, you're basically holding between your palms. Between your hand, you're holding the book. Okay? So what will be the tendency of this book to move up or down? Tendency, yeah. By default, what will be the tendency of this book? Book will move
Move
up.
down. Down.
Why? Which book you have which will go up? Book will have a tendency. See, I know that you will say, sir, what do you mean by tendency? By default, it will remain at rest. It will remain at. That is the reason I'm using the word tendency. That the moment I lose, right, the book a bit, it will have a tendency to fall down because of gravity. Okay. So why did I use this word tendency? Because you know that this book will be at rest. So how will you find the direction of friction? By observing the tendency of movement in general. In general, this book will have a tendency to move down. So friction will be down or up? Up. friction always opposes. Okay? Are you guys understanding? Friction always opposes the relative motion between two surfaces. So suppose if this book is there, okay, the same thing. Instead of physics, we have taken maths. That's the only difference. So if I'm holding the book from both the sides, what are the contact? First, this hand is in contact with the book. Same thing is happening on this side. So how many contact surface are there? Two. How many normal force will be there? Two. Okay. Next, by default, this book will have a tendency to fall where? Down. The moment I lose a bit, it has a tendency to move down. Why? Because of gravity. The weight will act in the downward direction. So the weight will make sure that, boss, if your hands are not here, the book will fall down. So friction will oppose it. So friction will make sure that is in which direction? Up. Is the direction of friction clear to everyone? How many type of contact force we have? Horizontal and normal. Okay. So here normal will act in which direction? My hand is pushing the book, right? Correct? And this hand also. So how many normal we have? So friction will act where? Up or down? How many surface are there? Two. So how many friction will be there? Two. Weight will be acting in the downward direction. So book is moving in the horizontal direction or vertical? Vertical, right? You don't have to worry about horizontal forces. So if book is balanced, 2F will be equal to how much? Mg. F will be equal to how much? Mg by. All clear? Any doubt in this? No doubt till here. You guys have not copied the question. Is equal to mg by 2. Now, is the book moving? No. When will the object not move? When the friction or the force is less than Fs max. Correct? If the friction is less than limiting friction, will it slip? No. The moment it is greater than Fs max, then it will slip or it will start moving. That's what we discussed. Okay. So it means this F should be greater than Fs max or less than Fs max? Less. Is this statement clear to all of you what I've written? Because if it is greater than Fs max, then kinetic friction will come into picture because object will start moving or object will start slipping. Okay? That's what we discussed in the last question also. So what is F equals to? Mg by. Now what is the formula for Fs max? Mu s into n. Mu s multiplied by normal force. So what will be normal force equal to n will be greater than equal to mg by 2 mu s. And what are we supposed to find out? How much force you should press the book. So when you're pressing the book, you're pressing the book with what force? See the figure? Normal. That's what we calculate. It's a good question. It's means after seeing the solution, you will feel it's very easy because hardly 2-3 steps are, but it's not a very easy book. You have to visualize things a bit. The concept should be clear. Most of the students mug up this statement, but you need to feel it that the force is less than Fs max means object will not move. That's what we discussed in the first class of friction. The moment you apply a force which is greater than Fs max, then the object will move or it will slip. Any doubt? All clear? Mark this question as important. Let's move to the next question. So in today's class, the question will be a bit challenging. Okay. This was a kind of moderate level question. Next to next questions will be a bit difficult, but there will be no change in the concept. Concept remains same. So you need to just learn how to apply it. All of you copy the question. So what is this figure? There is a block of 10 kg and the block is basically connected to this, you can say wall or support with a string. With a string. This is string. Okay. It is just connected. All of you just answer a few questions. Just give me 1 minute to answer a few questions. But this block is connected to this wall through a string. Okay. Will there be tension in this string? Why? My question is, will there be tension in this string always? No. Why? I'm pulling it, right? I'm pulling the block, and the block is connected to the string, right? So I am asking, if I am pulling the block and the block is connected to the string and string is connected to here, will this string be tight always? No. Why? Why, Mahogany? The force I am putting on the block. Okay. Block is connected to the string. String is connected to this. So won't the string be tight when I pull the block? That is my question. What do you guys think? Yes, string will be tight always. Okay. Anyone for no in the class? All of you understood my question? Okay. Anyone for no in the class? That there will be no tension in the string. Okay. You guys used your fundamentals very properly, but missed one small thing. If I apply a force on the block, and if the block doesn't move only, will the string be tight still? No. Okay. That is the reason I told you that today's class questions will be a bit tricky. You have to think a bit out of box. The block will not move only. Suppose I apply a force of, suppose 5 newtons, and the force is not enough to move the block by a centimeter also on the right side. Will the string be tight? No, because if block is not getting pulled, how come string will get pulled? If string is not getting pulled, will there be any tension? No. Okay. So try to feel the question. I always tell in physics, you just put yourself here. Suppose if this person, you think that you are here and you are pulling it, and then think what are the possibilities. Okay. Otherwise, you will miss some case. I'm talking about good questions. And that was the only thing which you need to feel in this question. After that, this question is very simple. Because most of us, if I am at your place, I will also answer as a student. So I will answer that because I will feel someone is pulling it, that will be tight. But we need to think, right, whether this will move or not. Right? If it is moving by 1 centimeter, 1 millimeter, or 1 micrometer also, the string will become tight. And then tension will be there. Take it, you can make a note of the statement, what I explained just now in your own words, and copy the question. Then we'll discuss the answer quickly. Write fast. We have to finish friction today, anyhow. Otherwise, class will get extended. So if you write fast, we can finish on time. Whether tension will be there or not, it depends whether block will move or not. Correct? It depends upon that. So in the first case, if I apply a force of 20 Newton, I will check whether the block will move or not. So to check whether block will move or not, which friction will you calculate first?
FS max.
Fs max, maximum static friction, right? Because if you apply a force which is greater than Fs max, it will move. If you apply a force which is less than Fs max, it will not move. If it is not moving, string will be not tight, no tension. If it is moving, string will be tight, tension will be there. The logic clear? Calculate. 30 for what? But Fs max. So calculate whether it will move or not. You are applying a force of what? 20? Fs max is 30. So will it move? No. Will there be any tension? No. First part done. Very good. Solve the second part. Mark the question as important. Whenever you want to check whether object will move or not, funda is very simple. Somehow calculate Fs max. Compare that with the force what you are applying. If force what you are applying is greater than Fs max, it will move. If it is less than or equal to, it will not move, or it will have tendency. First part, what? Tarika, what happened? First part, you have doubt? Did you calculate Fs max? Fs max is coming how much? Mu s into n. N will be equal to how much in this case? Weight. Students who have doubt in the first part can see here. I'm discussing that first part. First of all, you calculate Fs max. So Fs max is mu s into n. So normal force will be equal to mg in this case. So n will be equal to mg. So m is 10 into 10, 100. So mu s is 0.3. 0.3 into 100. So which will be 30 newtons. So for the first part, F is less than Fs max. So block will not move. It means string will not be tight, which means tension in the string will be 0. Second part. How much force you're applying in the second part? 60. Is it greater than Fs max? Yes. Will the object move? Yes. So the moment object moves by 1 centimeter or 1 millimeter also, I know that you will say, sir, it is connected to the string. It will not literally start moving. It will just get stretched, right? So it will get stretched by suppose 1 millimeter. So what will happen to string? String will be very tight. Will there be tension? Yes. So F is greater than Fs max. So block will have a tendency. Why I'm writing have a tendency? Because it is connected to the string. It will not literally move. But will it have a tendency or not? Yes. Otherwise, it will move. The moment you cut the string, it will start moving. Block will have a tendency to move. So string will be tight. And we know that when string is tight, there will be tension. T will exist. Copy quickly. I will explain the answer then. Anyone who has calculated can let me know the second part. You have to draw the free body diagram. Oh yeah, that's what is written, no? It's like what is supposed to find out? Tension. I have to calculate T. Draw the free body diagram for the second case. Everyone. All of you draw the free body diagram for the second case. Force is there. Tension will be there now. Yes. Friction will be there. Yes. Show all the forces for the second part. Tension, force, friction. All of you try. Don't worry about right and wrong. Try it. Should not have the fear. Many of you, I see that you don't want to draw free body diagram. You guys wait for me that I will draw. I will draw. I will explain. You guys also at least try. Should I erase the first part? All of you copied? Everyone? Check. So I am explaining the second part of the question, means I have explained the concept. Now I am drawing the free body diagram. So this is the block.
So is the answer 35 Newton?
35 Newton. I don't remember. Just give me 1 minute. I will tell you. Let me check this. So force is 60. Tension is always away from the object. Pulling. Tension will be left or right? Left. Now tell me friction ka direction. Same direction as T. Why?
Sir,
Opposite.
it's away from the force.
Correct. Very good. So I know it is not moving, but it has a tendency to move towards right. The friction will be in left. Relative motion. It always opposes the tendency of motion or relative motion. Friction will be in this direction. This friction will be which friction? Kinetic or static? Kinetic. Kinetic. When force is greater than Fs max, it has a tendency to movement or it will move. Whenever it has a tendency to movement, which friction comes into picture? Kinetic. See how good this question is. Free body diagram, friction, all the concepts, everything, tension, everything is used here. Force equation. These kind of questions you need to pick to practice or revise. Downward, mg, that is a weight. Upward, normal. So n will be equal to mg. So n will be equal to mg, which is 100 newtons. You guys have already calculated. So let's write the force equation. So we need to find what? Acceleration or tension? Tension. There will be acceleration will be zero, right? It is not moving. I know it has a tendency to move. It is not moving because of what? This string. Okay. So this force will be equal to what? Left ka force. So can I say 60 will be equal to E plus Fk? Is it correct? So 60 minus Fk. Fk means mu k into n. which will be tension. So 60 minus what is mu k? 0.25 into 100. Daksh, did you get what mistake you have done? You took mu s.
Sir, I told 35, right?
You took 35.
Yeah.
I heard 30. If you told 35, it's a perfect. Very good. Correct answer. All clear? Nice question. Perfect, everyone. Let's do the next problem.
Yes, sir.
Anyone having doubt? Any student? Okay. All of you copy this question. Mark this question as important. There are total 3 cases. I remember during COVID time, I gave this question in the school exam, thinking that, everyone, obviously. As a teacher, we were also new, right? That how will they respond? I just wanted to give a good question in the exam. Everyone answered. Mark this question as important. What I always tell to students, any student who want to become good with friction, this question ka 1, 2, 3 cases are enough to clear all your doubts. Just solve this question once. Friction mein you are good. Not telling you are best, but you will be very good. It's a very nice question. No need to write the whole thing. Just draw the first case. Don't draw all 3 together. Draw the first case. In each case, what are we supposed to calculate? Magnitude of friction and acceleration. Let's discuss the first case. Students who know how to do can do on their own. And if you feel that you'll get stuck, you can see on the board, I am also solving. So first case. So this object will have a tendency to fall down or up? Down. Because of its weight. So friction will be in which direction? Up. Any problem? Now, you are pressing this book or block by a force of 100 Newton. Correct? So contact force will be there in which direction? Yes. So can I say this will be normal force? Right? Makes sense? It is similar to that book wala thing what we did. So if you are pressing the block by a force of 100 Newton, the block will also apply a force on you, right? How much force? N. Contact force. In this case, what is the contact force or normal force, students? 100 Newton. Any doubt in this? Now, if the object is moving or not, how do you check? What do you calculate? Fs max. Calculate Fs max. So Fs max is equal to mu s into n. So mu s is 0.4. What is the normal force, students? 100. What will be the value? 40 newtons. 40 newtons. How? How is what? Ask. What is the doubt? Never finish in between. That's what is written on your t-shirt. Never finish anything. Huh? Tell me. The normal. There is a contact between the block and this wall, right? Normal force act in which direction? Along the surface or perpendicular to the surface? Perpendicular surface. And it will be equal to what? 100. Okay, Fs max is 40, right? Which force is responsible for the movement? This object will move because of which force? Mg, moment sensor, because of weight only it will fall down, na? Right? So I will check weight. What is Mg equal to for this object? 5
50
into
Newton.
50. So which force is responsible for the movement? Mg. Is it greater than Fs max or less than? So will the object move? Yes, 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 it will move. The weight of the object is greater than maximum friction offered by the surface. And weight is responsible for moving it down. So it will start moving down. Correct? So mg, which is the driving force. Don't see some students start telling, sir, here mg is the driving force. When the system is horizontal, mg is not. You don't see mg and all. You see what is the force responsible for the movement. Gravity will move it down. Mg, or you can say in the bracket, driving force. Driving means which is making it move, is greater than Fs max. Therefore, block will move down. When the object moves, what friction acts? Kinetic. So this friction will be Fs or Fk? Fk. That is the reason I didn't write in the starting. I was waiting someone will ask sir whether it is Fs or Fk. You will write this once you decide whether object will move or not. Once you do this calculation, now you know that object will move, then you will key Fk. If this mg was less than Fs max, will it move? No. Then it will be Fs because it is not moving. Any problem? Anyone? Huh? Huh? Yes. If it comes equal, also I'll use Fk. Less than no, obviously. If it should be greater than equal to, I use not less than. But it was having tendency to move, na? It was not moving because string was there. In the previous question, block was moving. Block was trying to move because you applied a force greater than Fs. But that string was making sure that acceleration is zero. So block will move down. So what is Fk equal to? Mu k into n.
30 Newton.
30 Newton? Okay, let's check. So mu k into 100. So this is 30 Newton. Okay. Mg is how much? 50. So what is the net force, students? 50 down,
20
30 up.
Newton.
What is the net force? 20.
20 Newton
What
down.
what is the mass? 5. 20 by 5? 4 is the acceleration. Acceleration equal to net force divided by mass. So 50 minus 30 divided by mass is 5. So 4 meter per second. In which direction? Downward. So they ask friction also. Friction is 30 Newton. What is the nature? Kinetic. Acceleration also 4 meter per second square. Downward. First part is solved. You can check if any doubt is there. Ask quickly. One. First part. Copy it. You guys try the second part. All of you try. Everyone try the second part, students. Same method, exactly same logic. First, calculate the normal force. So in this case, what will be normal force? 500. Okay? Because normal force will be acting in this direction, means towards left. The normal will be 500. Then you will find Fs max. Then compare whether it will move or not. If it is moving, Fk. If it is not moving, Fs. Everyone try this. Second part, this is the normal force. So in this case, normal force will be equal to 500. Friction will be acting in the upward direction. So second case we are solving, normal will be 500 newtons. So much? It's not moving? Yes, it will not move. Correct. So Fs max mu s into
So
N.
can I tell the answer?
Yeah, tell the answer.
Sir, so a frictional force will be 200 Newton and the acceleration will be 30 meter per second square.
Notice. So Fs max is how much? 200. What is mg? 50. So here you can see that the driving force, or you can say mg. Mg is responsible for movement, is less than Fs max. So if the driving force is less than Fs max, will the object move? No movement. If there is no movement, what will be the acceleration? Zero. And if object is not moving, which friction acts into picture? Static or kinetic? Static. Now, can you guys tell me what will be static friction equal to? 15. Very good. Excellent. Static friction means what? It is the minimum force, right? Or the force required to stop the object. If you apply a force of 50 in the downward direction, how much force you need in the upward direction to keep it at rest? 50. And that's what we discussed. Static friction is a self-adjusting force. And the role of static friction is to make sure that boss object is not moving. Right? Keep the important statements in your mind. That will simplify everything. There is no formula for static friction. Static friction is always self-adjusting, adjusting according to this driving force, so that object is not moving. If weight was 60, let us assume that static friction will be also 60. If it was 70, 70, 80, 80. This will keep on happening up to what time? Up to Fs max. The moment you apply a force greater than Fs max, static friction out of picture, kinetic friction into the picture. Static friction is self-adjusting. That is the reason Fs is same as driving force. Do write down the explanation for these small things. Now you will feel that it is very much obvious. I will not forget. But mark my words, we all forget after some time. And you will come to me and say, sir, explain me again these things. Make sure whatever you write, just decide that you write the explanation in one line, two line. You don't have to, after that, you will never have to read any book. I'm not against that you don't read any book. Why I tell that? Because you have to read all three subjects, physics, chemistry, maths. If you start reading books for all subjects, you will not have time to go into the depths. Okay? That's what I'm saying. Reading book is the best thing. Now you don't have that much time. Okay. Now what is the difference between case 2 and case 3? This time force is not getting applied perpendicularly. Force is getting applied at an angle. So this force will have how many components? Two components. One along this line, one perpendicular. Okay, that's the only difference. Let's solve it. So I will take the two components. So one component will be along this direction. So this will be, see, it is making angle with this axis. So this component will be cos or sine? Cos. So 500 cos 37. Then one will be like this. So this will be what? 500 sine 37. All clear, students? Go. If you remember this triangle, I asked you to remember this triangle. All of you remember this triangle, 37, 53. So
So
this is
cos
5.
37 will be 4 by 5, sin 37 3 by 5.
Okay. So cos 37 will be how much? 4 by 5. Correct. And sin 37 will be how much? Correct. So let's solve it. So this becomes how much? 500 into 3 by 5. What is the force? 300 newtons. If you calculate this one, this will be how much? 400. All clear? So this time normal force is equal to how much? 400. So this time normal will be equal to 400. The normal force will be equal to 400 newtons. All clear? Any doubt? Take it. Draw the figure quickly. Now after this, I want all of you to try. I will take 1 minute rest. I will wait for all of you to finish this. You guys know how to try this now. Whatever was the difference, I just explained. After that, exactly same. You will draw mg. Okay. In this, there's a challenge to find the direction of friction that you have to find. Whether friction will be down or up. Hmm. Why it will be diagonal? Oh, why you are guessing that? Diagonal friction will be always along the surface, right? Along the wall. Why it will be diagonal? Friction is not opposite to the force. Friction is opposite to the direction of movement or tendency of movement. Let us see who answers it correctly. I just asked one simple question. What is the direction of friction? Up or down? It will be down. Okay. No? Okay. Two of you are telling down. Anyone else in the down team? You don't have to change your answer. I didn't tell that down is correct. I'm just asking.
So it will be up itself. Object will
It
not
will be
move.
up itself. Okay. Take it. Noted. Down. Take it. Now three of you are telling down and three of you are telling up. Anyone else who is feeling that friction will be in the downward direction? There's no rocket science in answering that. Down or up. It's very simple. It's very simple. You just see that where is the net force act. Okay. Chalo. Friction will be down. Okay? So whoever told up, you didn't observe the figure carefully. How much force is acting in the upward direction? 300. And the downward direction, what force will act? Mg. What is mg? 12 into 10, 120 newton. So in the upward direction, you have 300. Downward direction, you have 120. So net force will be in which direction? Up or down? How down? 300 is it up, 120 is down. It means net force of 180 Newton will be in which direction? Up. Tendency of movement will be in the direction of net force. The tendency of movement will be up. Friction will be. What is rocket science in this? Simple. You don't have to think anything out of the box. Just draw the forces, observe. You guys know the statement properly. You guys know that. Friction will be in the opposite direction of movement for net force. The net force, weight 120 down, 300 up. Net force 300 minus 120, 180. In this case, the driving force or the net force will be 300 minus 120, which is 180 in
So
the
so object
upward
will move.
direction. Yeah. So driving force, let's check whether it will move or not. So driving force in which direction? Up. So friction will be in which direction, students?
Downwards, sir.
Okay. Let's check whether it will move or not. See, I just wrote the friction ka direction by the tendency of the movement. Means it will have a tendency. Whether it will move or not, we'll check. How will we check? By comparing what? Fs max. So find Fs max. What is Fs max, students? Mu s into n. What is n here? 400.
400,
So 0.4 into 400. What is the value?
160 Newton.
160 Newton. So driving force is greater than Fs max or less than? Greater. So will it move? Yes. You compare with what? The force which will drive the object will move the object. Why there is a confusion? See, when I see you guys get confused in this, it means that you guys are trying to remember. It's common sense. The net force is greater than maximum friction. It will move, na? It will move. There's nothing to remember in that. So driving force or net force is greater than Fs max means it should move. Block will move. All clear, students? Okay.
Sir, is the
Any doubt?
acceleration 5?
Acceleration is 5. Okay, I will check it. Just 1 minute. Any other student who has got the answer can let me know. I got one answer as 5. So I am drawing the figure again, student, this time. This time friction is where, students? Down. Fs or Fk? Fk, because
FK.
it is moving. Because it is moving. Where is the driving force? Up or down? Up. What is the value? 180. So I need to find acceleration. So first of all, find Fk. Mu k into n. So mu k is 0.3.
120.
120. Correct. Now see the forces 180, 120. Where the object will move? Up or down?
Upward 60
180
Newton.
forward. So acceleration will be net force divided by mass. So 180 minus 120 divided by 12. So this is 60 by 12, which is 5 meter per second square. in the upward direction? This is one of the best question of friction. I think you guys can also understand by seeing the working what we have done here. It makes all the concept clear. Static, kinetic, direction. Okay, that is the reason I told. Anytime you want to revise friction, just read the statements quickly, solve this question, means you're very good in the friction if you're getting the answers. If any doubt is there, let me know before we move to the next question. These questions are not in your textbooks. Okay. Okay. Should we move to the next problem? Done? Copy the figures. If you don't want to, this question is not necessary. You can just ignore it. Just draw the figure. No need to write the story. The figure is self-explanatory. Just write the data given. What data is given? Only coefficient is given. Write down this thing. Only this line and draw the figure. After that, nothing to write. All of you try to draw the free body diagram. Everyone draw the free body diagram. Just to slip means it is just about to move. If it is just about to move means what? The force what you are applying should be equal to what? Fs max. See, whenever they use the word tendency to move or just about to move or just about to slide, it means the force what you have applied is almost same as Fs max, or you can say just greater than Fs max. I gave the example that the yellow light on the traffic signal. Yellow light on the traffic signal says that boss, start the engine, ready to move. Same thing. When they say tendency to move or about to slide means force what you applied is just greater than Fs max or equal to Fs max. Okay, if Fs max is 50, you applied a force of 50.00001 Newton, just greater than that. That is the meaning of tendency to slide or tendency to move. Don't worry about how to solve. I just want you guys to at least draw the free body diagram of block A and block B. That's it. You guys do that much. Also, if you guys do means 60% of the question you have solved. Draw the free body diagram of block A and block B. That's it. There will be no tension. Why tension will not be there? Huh? The question says there is no tension. Yes. Tension will be. That doesn't mean that there is no tension. Okay. Inextensible means it's not like working like a rubber band. That is a meaning. See, that is a meaning. Inextensible means it's not like it will the kind of rubber band it will stretch. Okay, but it will be tight. Inextensible doesn't mean tension is zero. Chalo. You have drawn the free body diagram, right? Friction will be there. Friction is written, na? There is a friction on horizontal table. Friction will be there. So what will happen? Because of this block, this MA will start moving forward. Chalo, take it. Let me draw all of you match your free body diagram whether it is correct or not. Free body diagram should be correct. If something is missing, correct it quickly. So block A, weight will be MAG, normal applied by the ground. Friction will be in which direction? Left. It will have a tension T. This is 37. So this will be what? T cos 37. And what will be the component here? T sin 37. Any problem?
No,
It
sir.
is it's just about to slip, means has a tendency of movement. So in this case, what will I take acceleration as? Zero. Zero. When the object has just the tendency to slip, at that time, what will be the acceleration? Negligible. Negligible. If I draw the free body diagram of the block B, MBG, weight, the spring, there will be tension. Whatever tension will be in this string, same tension will be in this string. Why? Because string is same and string is massless. Massless string has same tension at each and every point. We have discussed that. So what will be T equal to, students? MB. All clear? Any problem in this? Now see here, everyone. If you see here, in the upward direction, how many forces are there? Two. And downward one. In this case, N will be equal to mg. No. I took this question intentionally to show you and make you clear that normal force doesn't mean weight always. Depends upon the situation. In this, what will happen? So sum of these two forces will be equal to mg. So you will write T sine 37 plus N equal to MAg. So what will be normal from here? N will be equal to MAg minus T sine 37. So this is the normal force. Right? Now, T cos 37 will be equal to what? F. Tell me. We took the component of this tension. Na? So once you take the component, now this is over. I have resolved this force in x direction and y direction. Means now there is no root of this tension. That is the reason I'm resolving. Because I'm going to solve separately for x direction, separately for y direction. Now this tension is out of picture. Ignore it. T cos 37 will be equal to how much, students? Friction. Okay. Now, so T cos 37. What is the formula for friction? Coefficient of friction multiplied by N, right? Do you have N already? Yes. Substitute. So mu into MAG minus mu into T sine 37. I just substitute the value of N. Now what will I do? I will bring all the T terms together. If I bring the T term together, what can I take common, students, from both the term T, right? So T time of cos 37 plus mu times of sine 37 equals to what? Mu times of MAG. Is it clear? I just move T term here. So this is my second equation. So we have first equation and second equation. See if any doubt is there, let me know. Check the steps. Are you guys clear why acceleration is taken as 0? Because it is just about to move. Acceleration will be negligible at that time. And remember these things. If it is tendency to move, means force is almost same as Fs max, and acceleration will be 0 at that time. Okay. Should I erase this part, this diagram? All of you copied? Anyone drawing the diagram? Anyone? Okay. Now divide second by first. So when you divide second by first, T and T will get cancelled. So we'll have cos 37 plus mu times of sine 37 equal to mu times of MAG divided by MBG. GG gets cancelled. What is cos 37, students? 4 by 5 plus mu time. Mu is 0.5. What is sine 37? 3 by 5 is equal to zero point 0.5 times of MA by MB. Can you see that we have solved the question? That's what they have asked. MA by MB. We have finished. So solve it. Tell me the ratio. Very nice question. Very beautiful problem there.
11 is to 5.
11 is to 5. Correct. Most of the question you are seeing tension, acceleration here. They asked mass ratio. Okay, it's a good question. So 4 by 5 plus 0.3 equal to 0.5. So this is how much? 0.8.
0.6.
0.8 plus 0.3 equal to 0.5. MA by ME. So this is 0.11 by
1.1.
0.1. Acha, oh, correct. 1 point. Yes. Answer will be 11 by 5. This is the answer. Clear? Like, so do practice these questions once you go home. Practice these questions. Okay, I intentionally took these type of questions so that basically you go a bit out of your comfort zone. Okay, and once you understand that these things are not tough for you, you know how to draw free body diagram, you know how to basically write the force equation. These things are not that difficult. Okay, should we move to the next thing? So now we are towards the last topic of friction. How much time we have? 10, 15 minutes. 10 minutes? Check. 12. All of you copy the question. Okay. So this is an important concept of your friction. Where how many blocks are there? Two. Copy the question quickly. The question should we discuss? Everyone, anyone writing? Okay. Chalo, let's discuss this question. So basically, what type of questions are these when we have multiple blocks and we have friction between them? So what are they telling that? There is no friction between the ground and the block. Friction is present only between these two blocks, right? There is one more version of this where friction will be between both the blocks as well as with the ground. That I have not taken. Okay. That I will take once you become comfortable with the topic. That is a difficult version of this question. So now the friction is only between the blocks. So calculate the maximum possible value of force so that both the bodies move together. I need to find out how much force I need to apply so that both the bodies move together. If both the bodies are moving together, they will have same acceleration or different? Same. So let's find out what is the common acceleration. What is the formula for acceleration? Net force divided by total mass. Correct? Force divided by total mass of the system. So why did I write common acceleration? Because it is telling that, tell me how much force I should apply so that both of them are moving together. So if it is written that they are moving together, I will take the common acceleration. I will draw the free body diagram. This is something interesting. So see it carefully, the free body diagram. So I applied a force of F here. Both of them have friction. So this block has a tendency to move in which direction? Right. So friction will act in which direction? Yes. Now, this friction is acting between both the blocks, right? So same friction will act on this block in which direction?
Left.
There is a friction between small block and capital block, big block. So this friction will act on this block in the same direction or opposite? Opposite. Why? No, you have to. This is resting on this, no? This is resting on
Oh,
this.
so to balance the object, you need to have the
Like,
friction in opposite direction. Otherwise, it will
so,
slip off.
so this friction will be on this object in which direction? Right. I will tell you two ways to understand that. I got one correct answer. Very good. I'm explaining two ways. First, action reaction. Okay. If this is the action, reaction will be on which object? This. In same direction or opposite? So friction will be in which direction? Clear? See, these two objects are in contact. Friction is acting on this object in left direction. Is it clear? Why? Because it is moving in the right direction. So if this is action, reaction has to act on this object. Reaction acts in same direction or opposite? Friction will be in which direction on this? Right. Okay. If now second thing, listen to me carefully. The force is acting on capital or smaller one? Capital. So what will be the tendency of smaller one? To remain at rest. Friction will do what? Oppose. Friction always opposes the relative motion. So friction will try to make it move in which direction? together. So friction should be in which direction? Left or right? Right. There is no other force acting on this. You only think of it logically also. Forget about physics. If I am telling that both of them should move together, there should be some force on this, right? Is any force acting on small m in the horizontal direction? No. This capital F is not on small m. It is on capital M, right? There has to be a force which will move it in the right direction. Which force it will be? Friction. If that is also not clear, if anyone is not able to get that feel, I gave you one simple way to understand. Again, repeating. We know friction is acting on this block in the left direction. Why? If this is action, there has to be a reaction. Reaction is always equal and opposite. Equal magnitude, opposite direction. So make a note of that because this thing is something new for some of you. That why the friction is in this direction. You can take the example of Newton's third law. Okay, now this is capital Mg. This is the normal applied by the ground. This is the normal applied by small m. That is the reason I didn't show any friction on the ground. Na? There is no friction between, I didn't show any friction on the ground. This is the friction between small m and capital M. These two surfaces are touching. All clear? Just see the free body diagram, everyone. No doubts? Can you guys see the normal? This normal is applied by which block? Small m. This normal is applied by which block? Capital M. Both are in contact, right? So wherever contact is there, there will be contact force. So this normal is applied by small m on capital M. This normal is applied by capital M on small. All of you clear with free body diagram? Very good. Yeah. A bit surprised means I'm surprised in a good way, but everyone has understood this free body diagram. Chalo, very good. Excellent. Chalo, let's move ahead. So the system is moving in which direction? Forward or backward? Forward. With what acceleration? Common. Common. Now see on the board. The last step is left. Free body diagram is clear. Last step is left. Which force is responsible for moving small m? See in the free body diagram. Friction. See it
Friction.
carefully. Friction. There is no other force in the horizontal direction. So F will be equal to what? Mass into common acceleration. Any problem, students? So small m, what is the common acceleration we calculated? Capital F divided by small m plus capital M. Any doubt? Okay. Give me one more minute. After that, you can copy. Is there any slipping between small m and capital M? Read the question. Any slipping is there? No. It means this friction should be greater than Fs max or less than. Slipping is not there. Means it is not moving. It should be
Less
there
than.
less or more.
Less than.
Less than. Why it will be greater? If you apply a force which is greater than Fs max, it means you are breaking the barrier. You can move. Okay? So this force or this friction, if it is less than Fs max, then only it will not move, right? No? Chapter is over. F is less than Fs max. Okay? No slipping. So F is m into capital F divided by capital M plus small. Less than mu s into n. Student, tell me which n will you use? N between small m and capital M or n applied by ground? Which normal will you take? Normal between small m, capital M? or applied by ground? Between both the blocks. Because friction is also between both the blocks, right? So use which normal? Between the blocks. Common sense. Hai. The friction is between both the blocks. So I will use the normal between both the blocks. So what is this normal equal to? Mg. Which mg? Small mg. So if you apply a force less than this, both of them will move together. If you apply a force greater than this, both of them will not move together. That's what is the second part. Mark this question as important. Right? Any doubts, students? Let's discuss the last part, the most important part, quickly. First part is also important, but second part uh, is more trickier. So now they are telling that if you apply a force greater than this, so you tell me that will the objects move together? No. What will happen? There will be slipping. Or you can say both of them will move with different acceleration. This will move with the acceleration a1, this one will move with the acceleration a. Clear? Because if they have different acceleration, will they slip relative to each other? Yes. One will move forward, other will move backward relative to each other. If both of them have same acceleration, then only they will move together, right? If you apply a force greater than this, then what will happen? So let's draw the free body diagram. There will be a small change. You guys have to draw the free body diagram again. All of you have to draw the free body diagram again. This time there will be no common acceleration. So this time it will be A1 and this time it will be A2. A1 and A2. And they are moving relative to each other. So this will be Fs or Fk? Fk. Same free body diagram, but this time the acceleration will be different. A1 and so for the small block, Fk will be equal to how much? Which force is responsible for moving this friction? Fk will be equal to what? M into A1. What is the kinetic friction ka formula? Mu k into N. What is N equal to? Mg. Mm gets cancelled. So what is A1 equal to, students? Mu k into G. Done. If you apply a force greater than the previous one, both of them will flip relative to each other. They will have different acceleration. If you see the free body diagram, the only force responsible for moving M is Fk. So force is equal to mass into acceleration. Any doubt? Force which is responsible for moving this is Fk, mass into acceleration. This time we are applying a force greater than the previous one. That is the reason both of them have different acceleration, A1 and A2. Not common. Now, for the second block, all of you see the force. What is the net force? F minus Fk. F minus Fk will be equal to mass into acceleration. So what is Fk? Mu k into N, which is mu k into mg. So this will be F minus mu k mg divided by capital M. This is the acceleration. So very good problem, okay, where you learned both the cases, where what will happen if you apply a force which will make sure that both of them move together. If you increase the force, then they will have different acceleration. Kinetic friction comes into picture. So find their acceleration. Okay. So in this, one more case is their last class. I'm not extending the class. I'm just giving you that homework. Okay, and then we will wrap up the session. Class is almost over. Almost means over only. Just draw the homework question and then we'll close the session. All of you copied this? Anyone writing? Exactly same question. But what is the difference? This time force is applied on smaller. You don't have to write this whole question. This is a part of the previous question only. Exactly same thing you have to find out. But what is the difference? Force is applied on small. Draw the figure. I want you guys to try this. We'll discuss the answer in the next session. Exactly same, 100% same question. Only difference is F is not on capital M, it is on small m. So draw the figure and do complete the homework. Tomorrow I will discuss and ask the answer to all of you. Okay. So this basically wrap up the friction. Tomorrow we'll discuss this question and we are going to start uniform circular motion. So start solving the worksheet. I will send the worksheet of friction also today. Okay, I will take the doubts and Saturday there is a exam on Newton's law of motion. Complete chapter. Bye guys, good night.